Welcome to Physics in the AM. Shindelka here, and we're looking at kinetic energy, and it's just a brief introduction to it. We're going to look at two ways to find kinetic energy. First of all, what does the word kinetic mean? Kinesiology, study of movement, though. The human body itself, but movement, yeah. So, kinesiology. Kinematics was the speed, distance, time, acceleration stuff that we did without looking at forces. That's dynamics. So, kinetic energy is the energy of movement. Thank you. So the energy of movement, two ways we can find it. You can do work, and it's equal to the difference in final and initial kinetic energy. That's the change in kinetic energy. The other one, double checking, everything cool? Wellness check here. Okay. Then there's a formula for it. 1/2 mv squared. You'll notice something about that. Like momentum, it's only reliant on mass and velocity, not acceleration. It can be going at a steady speed. And we'll find something out about conservation of kinetic energy, how it works. How much work must be done, so work is energy, to accelerate a 1,200 kilogram truck. 13 meters per second to 28 meters per second. That's highway speed, about 100. So, it's fairly easy. How do we go about doing this? Well, work equal to final minus initial kinetic energy. Okay. So this means I'm going to just calculate each of those separately and then put them together. How's that sound? I sometimes use final and initial. I sometimes use 1 and 2, second and first, or whatever. I'm going to call it initial though. So our first one, 1/2 mv squared. I'm just writing down the formula because I'm getting used to it. 1/2. And in physics, the basic mass unit is kilograms, so we're going to keep it at 1,200. And then 13. Yeah, 13 meters per second. Okay. That's a square. It has to be squared. You do that, you get 101,400. Make sure you square this. I'm gonna assume you know how to use your calculators and how you put 1/2 decimal points. Square it. Okay. How does that unit work? How do I get joules out of mass and velocity? Well, because you got a kilogram, meter per second squared with meter again, so meter squared. It works out in joules. So then the next final, I'll just jump straight into the formula. And 28, square that. And when we do it's 470,400. Last, the work is the difference. Final minus initial. Now, I know I kept more sig figs than I needed, but they actually subtract out these things. So the work done. Now we're going to talk about what this work was. 369,000 joules. What are you assuming did the work? And this 369,000 joules of energy, so 369 kilojoules, is how much energy the engine provided the vehicle to get it up to 100 kilometers per hour. Does that make sense? Has nothing to do with the time frame. It could have been over a long period of time. It could have been a short period of time. It doesn't matter. This is not a rate. That's what I'm trying to emphasize here. Okay? So it could be slow, could be fast. There's a big difference, and that's power, right? That's the rate. That's a difference. Now, any questions about this? I just wanted you to see how the formula works, then how you can subtract it. Now, collisions. Momentum's always conserved in collisions, and we are going to be quizzed, and I'll go over those assignments on Monday for your quiz on Tuesday, right? I call it a quiz because it is just one page, two sides. Yeah, the momentum that you handed in? Yeah. Just that. That's why I'm saying quiz, not test. Tuesday. I just put it up. Yeah, okay. I just mentioned we're going to go over it on Monday, the assignment back. So you'll all get it back. We'll see if I get them all in right now. Actually, maybe I'll go over them, whatever. Anyways, momentum is always conserved in a collision. But mathematically, it's kind of funny. MV, right, conserved, okay? Elastic collisions, when objects bounce apart, both kinetic energy, 1/2 mv squared, and momentum, mv, though they're both conserved. But if you have an inelastic collision, momentum is conserved, but kinetic energy is lost in an inelastic, where they stick together, okay? Just it's up. So, page 287 in your textbooks, numbers 1 through 3. Take a look at that. I'll just bring it up real quickly. 287 plus 14. Is it? Oh, by the way, we're sticking to just driving down the road kind of kinetic energy. You can have rotational kinetic energy, which we will not calculate, just spinning. Earth has rotational kinetic energy, right? There's other types of kinetic energy. We're just sticking to the linear motion ones. And we're going to talk about potential in a minute. 287 now. Oh, should I go back? There we are. These problems, right? Skater. So it's calculating work very much the same as we did. Initial and final energies, calculate the work. Common. Kinetic energy calculation. Okay. 1, 2, 3. That's what you guys are going to work on. This is not going to take you a long time. Okay? But I expect you to have them done pretty soon.